Okay, we look at the equation 2 raised to the x squared plus 8x minus 50 equals, excuse me, 16. It follows by rearranging this equation to logarithmic form in the obvious way that x squared plus 8x minus 50 equals log base 2 of 16. So what kind of an equation is this? We haven't seen an example of an equation of this nature. Well, the equation is just a quadratic equation. You have a square, an x squared, you have an x, and then you have a bunch of numbers unaccompanied by the variable. Log base 2 of 16 is just a number, and as a matter of fact it turns out to be 4, but we won't worry about that because in general it might be log base 3 of 16, which is just an irrational number that you have to approximate using a calculator. So whatever this is, it's going to be just a number. So we rearrange this equation to standard form, and here it is in standard form. This is the form ax squared plus bx plus c equals 0, with a, the coefficient of x squared, just being 1, b is 8, and c is just the number you have that isn't attached to an x squared or an x, and that's negative 50 minus log base 2 of 16. That's what c is. So the solution is x equals, well, quadratic formula. I'm not going to read it to you. But we write out the quadratic formula. We identify a, b, and c, which we just did, and we plug it in, and we get this. Okay, so what do we do with this? Well, we simplify under the radical. We simplify the discriminant, meaning we multiply negative 4 by negative 50 minus log base 2 of 16. Well, that's just negative 4 times negative 50, which is 200, and negative 4 times negative log base 2 of 16, which is just 4 times log base 2 of 16. Now, when you look at multiplying 4 by log base 2 of 16, you probably wonder, what in the world am I going to do with that? Well, there's no rule that allows you, well, actually there is a rule that you can do things with, but you wouldn't want to in this case. But you don't know how to, get that 4 inside of a log base 2 of 16. We're going to see a rule that would allow you to do that. But for right now, that's just 4 times log base 2 of 16. That's all it means to multiply 4 by log base 2 of 16. You don't have to do any more than that. Okay, well then we add the 64 and the 200, get this form. And then, people wanted to apply the rule that log base 2 of 16 is log 16 divided by log 2. Yeah, now we're going to do that. There's no point in doing it earlier. It would have just been extra stuff to write down and an extra opportunity to write something down wrong and mess it up. We keep it simple until we need to do something with it. And now we write it out this way. And of course, log base 2 of 16 is log 16 over log 2, 4 times that. If you're going to want to divide that 2 into that 4, or multiply that 4 by that, you can't do that. There's no rule that allows you to do that. So if you don't have a rule, you just leave it the way it is. And then we distribute the division by 2. We get this. Then we can divide the negative 8 by 2 to get the negative 4. But we're then going to have plus or minus this square root over 2. Now, I will say, we could factor a 4 out of this expression. And the square root of 4 being 2, we have a 2 over 2. So this could be written as the square root of 66 plus log base 16 over log 2. If you want to do that, you can, but since this is going to be punched into a calculator, not necessary to do that, although in exact form it would be a good idea to do that. And you should understand how to do that. Okay, but if we're going to key it into a calculator, this is just as good as any other form. And when we do key it in, this expression is going to then be equal to approximately 8.4. So I said our approximate solution then would be negative 4 plus or minus 8.4. And that's going to either give us plus 4.4 or negative 12.4. Now there's one more thing we can say about this, and that is that 16 turns out to be a power of 2. Now when this number is a power of this base, you know, like a whole number power, then the log is going to be a whole number, because since 2 to the 4th equals 16, it just follows that log base 2 is 16 equals 4, and vice versa. So we could have substituted or written, instead of the log 16 over log 2 and keying it in with the calculator, if we noticed this, we could have just put the 4 there and gotten this expression. That would have been a little simpler than keying this in, but either way, it's not difficult to get your approximation. And this would involve an approximation too, so that's what we do. Now we're going to switch gears and look at a couple of laws of logarithms and talk just a little bit about why they hold.